Hey everyone, welcome to my channel. If you are interested in speaker design and improving sound quality, subscribe and join us. In the continuation of the previous video, to make the said template follow this direction, global frequencies. Note that you need to create a fixed template only once, and after that, all the folded bass horns can be simulated by a useful method. In this case, we need to evaluate the low frequencies, so select the lower frequency as 10, and the higher as 2000. 50 means the software calculates 50 frequencies between 10 and 2000. You know that the higher the n, the slower the calculation speed, and the more accurate the results. Now, click on Global again, and select BEM parameters. On this window, select Z. As you know, it creates a symmetry on the axis. Something like this. Why a symmetry? Because the software divides the shape into two parts and only calculates one of them, then multiplies the result by 2. It makes the calculation so faster. We need to import the driver specs into the software. Click on LEM below and on the left. Double-click. ELEC DYN driver is all we need to import the specs. We need some grounds and an electrical source. Drag them or click on Apply. Do it with me and connect all these wires. Put this ground connector here. We'll need it in the next tutorials. After that, select 2 acoustic radiators, one for the front cone created in the previous tutorial, and another for the rear cone. After completing this simple circuit, click on ELEC DYN driver. First, connect this part to the driver created in the BEM section, front to the front and rear to the rear. The upper radiator corresponds to the front cone. Connect it correctly to the related BEM part, then the lower radiator. You don't need to import all the driver specs. Import MMS. After that, the free air resonance frequency. You'll see the software calculates KMS and RMS automatically. Note that this is a very good format for entering the amount of MMS in grams. If you click on KMS, you'll see the software has calculated CMS and VAS. The values are really close to the driver's datasheet. After entering QMS and QES, BL and QT are calculated automatically. Compare the result with the driver specifications to see if you did it right. To enter LE value in millihenries, do it like this. As you can see, the QTS value calculated by the software is really close to the driver specs. It is assigned to check if we've entered the information correctly. Observation tab is a place to define our desired outputs. I select radiation polar to see the directivity plot of the system, and LE pot and flow to see the electrical impedance graph. We need to adjust some parameters for the radiation polar. If this axis is X and this is Z, this direction will be XZ, and we must select it on the position tab. Note that ZX is different from XZ. Do the same for the other tabs. For LE pot and flow on the observation tab, select S1. It causes the software to calculate the electrical impedance from the source view. The template is completed, and everything is ready to simulate our desired folded horns.